Okay, so section 2, application techniques. So this is just going to go into the different ways that you can set up an OL application. And this is just useful to know because there's a lot of words floating around. And when people try and sell you products and get you to use them, and when you do use them, you need to know what they mean and what it means for what the output is supposed to be. So there are just some common parameters that, sometimes they let you mess around with if you play with LLMs online. Temperature is basically like how creative it can be. By default, they're non-deterministic. They don't always produce the same output, no matter what you give it, but they're more likely to produce very, very different output if you up the temperature on it. If you lower the temperature on it, it's more likely to produce same-ish content over and over again if you give it the same prompt. That's mostly what that is. Top P is, okay, it's generating a list. Okay, what's the next word that's going to be in the sequence? Is it going to generate a list of 20 words or 10,000 and then select from whichever it thinks is the most? Max tokens, how much output it is that you want it to produce. This is a big thing, just resource saving, things like that. Frequency penalty, there was like a problem with some LLMs, especially earlier on, where it would start repeating itself over and over again and and keep using the same words over and over again. Sometimes this still happens. You can give it a penalty for like using, fancy words over and over again, and that should sort of reduce that behavior. Then stop sequences is another thing that you can play with to like, there's a problem with how do you get an LLM to stop talking? It was more of a programmatic issue, but there's like a whole field dedicated to producing good stop sequences. This is a way to fine tune or train your own large language model. So then, like Facebook, I mean, they haven't done it for a while, but they put out open source large language models, and you can sort of fine tune it to do like a specialized task. So especially for something like healthcare, people have trained it on like a bunch of PubMed text. So like it's really, really good at, healthcare stuff and biology and chemistry and all sorts of stuff. The first way to do it is full fine tuning, which is basically you take the model weights and then you continue training it as if they never really stopped training and just keep feeding it more text, but you're feeding it specific text. This is expensive, especially if you're trying to fine tune a very, very large model, which, why wouldn't you want to do that? They're already really, really good, and fine tuning it should maybe perhaps make it better. Although this is not always the case, but that's like the naive, like this is the first thing that people tried doing. You basically just continue training it. LoRA, it's like low rank adaptive training. You basically create a new layer of weights and then you fine tune just that one layer. So it's a lot faster. So that everything that comes out of the model gets passed through this one final thing. I guess you can put it in the middle too. And it sort of pokes the output to be more like what you want. They do this a lot for image generation as well, audio generation. You can make specialized LoRa's for a bunch of different things. And this is a way to, again, coax the output to be more like what it is that you want, but programmatically and computationally, it's much cheaper than full fine tuning. And then QLoRa, it's quantization. So then it uses reducing the precision of some of the parameters so that it's even faster. And you can train it on like sometimes even on the fly. So that's just one of your options. So this is a slide about quantization, which I just brought up. You can basically just change, like if you're from like a computer science background, you know that there's like different ways to store numbers to different like levels of precision. If you didn't know, now you know. And basically you can reduce the size of a model, which is important in being able to run it quickly based on like which GPU stack you are. You can run more models on the same hardware. You could run a smaller model on smaller hardware by reducing the size of it and also the computational power required to actually run the models. So quantization is something that you might see from time to time. This is a representation of RAG, or retrieval augmented generation. The idea of RAG is that you give your large language model a database of knowledge. You could give it like up to date, right? Which they just came out with. You could give it, all the documents from HR, and then you can have like an HR bot that talks about all the policies from HR. And what it does is it asks you, prompt it, you're like, ask it a question. It uses a querying system to find which things, articles, chunks from articles from the database are most relevant to your question, and then adds that, like tacks that onto the query to feed to the LLM in addition to your question, so that when the answers, it's supposed to answer with the knowledge from the knowledge base that your querying system determined was the most relevant to your question. So that it uses the retrieved documents. If you've ever used a large language model that talks to the internet, it sort of does this. Like it does an internet search and then it feeds those web pages to your large language model, and then your large language model is supposed to generate from those web pages. So that's related to that. Again, this constrains it from hallucinating facts a little bit, although it's still possible for it to do that. It's just far less likely. It's constrained by your ability to, correctly find the correct articles to feed the model based off of your query system. So then that's one of the limiting factors. And the other thing is large language models can still just make stuff up, even if you give it the right context. You can give it too much context. The context can get lost in the middle. All these problems are still relevant here, but again, this reduces some of those hallucinations quite a bit. And you can find this everywhere. They use RAG all over the place. Agents. So agent is basically just a fun industry term now for a large language model that you make do something. So can you make it do a task? And then you can like string a bunch of agents together to do like little mini tasks and then, put it together and then create an output. But you can give them memory and then you can also give them tools. So again, like the web search that we were talking about, RAG, you could give it actual API access to something that does stuff on a computer somewhere else. The world is your oyster. The extent to which you actually want to deploy this is, again, up to your use case. We're not quite at the level of having agents autonomously make decisions about patients, but it seems to be what people want this to do eventually. Different types of prompting that you can sort of force the large language model to do. And it's basically just you put stuff into the instruction set, but you ask it a question and then it sort of answers it. You can also have it sort of feed its own thought process back into itself. This is a little bit different than reasoning models, but we'll talk about that in a little bit. But like chain of thought prompting is one of the things that came out early to try and solve hallucinations. Again, it sort of reduces hallucinations a little bit, but it's not entirely still fixing it. This is what we mean by the reasoning model. So this is just continuously feeding its own thought process and when it's generated before back into itself, sometimes in a new context window to just sort of say like, hey, is this correct? Is this right? Think through the problem first. And it's like a lot of it is just like a prompt injection from like not your side, but from like the application side saying like, hey, think out loud about this. But like, again, it's not thinking, it's just, generating text that amounts to like how you might think about this problem. It seems to improve output. It seems to correct a lot of things. Again, they're still capable of hallucinating. They can and they will, because that is how they were constructed. And then this is not technically by itself a technique on how large language models are applied in applications, but is an essential part of it. And if you're ever in the case where you are put in charge of or part of a team that's putting this together, this part is super important. This is, you need to build a system where you can see where and how the system is failing. This is sort of applicable to everything. Like if you've ever taken business classes, you'll be like, duh. Basically, you need to design the system and program it in a way so that you can test it at each individual step, especially if you have like a multi-agentic system. At which point are the agents failing? Is it just one of the agents? Is it all of them? Is it when you pull it together? If you have a RAG system, where is your RAG system failing it? Is it in the generation once it has the documents? Are you feeding it too many documents? Is it not? Are you not able to provide the correct documents from the query? Like you need to be able to develop a system where and develop metrics to find out and evaluate how well is this application accomplishing what it is that we needed to do, and how can we tell where this is going awry? So there's that.